Keenan. So I came across this a while ago. I don't know. So I was born in Africa, in Kenya. And so when I discovered the Silicon Valley company building drones and actually starting out in Africa, I was obviously very interested in figuring out what they're doing. So this for me was it was my inner geek, and also just trying to understand, I left Africa as a teenage kid, and I'm curious what it was like to do business there as a tech company. So we'll hopefully get to cover some of these things. But Keenan, welcome.
Thank you.
We'll start with tell us a bit about yourself. How did you end up here? Why robotics?
Yeah, so I definitely started my career in robotics, always been into it. I kind of oscillated between kind of product design and robotics, depending on different roles I've had in a lot of different places. And yeah, started in medical robotics, which I really enjoyed, but got a little disillusioned with the medical device industry, and moved from that to when I went to Stanford for grad school, started what became ROS, Robot Operating System. You can check it out at ros.org. If you're ever going to do something with lots of sensor data and try to process it and make things move, it's a really good framework to start with. Spent about 7 years building that community, getting that funded, getting that off the ground, giving it a really good name, and a really
very original
name. And and then after that, I decided once we started what used to be called the Open Source Robotics Foundation is now called Open Robotics, which you're going to talk to soon. Sounds like next week, which is great.
Yeah.
I decided I wanted to figure out what my next thing was going to be. And so along the way, I had started a couple of companies, one that became successful, you've probably heard of, called Nito Robotics.
Mm-hmm.
And worked on a bunch of other things you've never heard of because they weren't successful at all. And then I knew I wanted to do something that would really matter and something that I really believe could scale. And that took a long time to find, not just the co-founders to do it, but of course the actual application. And that took a few years. And then 2014 was when Zipline really got going.
Cool. So I saw that you had left a PhD program in philosophy to.
No. That was robotics. That was robotics.
Oh, so you left a PhD. Sorry, you left a PhD program in robotics.
Yeah.
To go do this, and are you going to finish the PhD program, or is
that was
the
to go
PhD?
be Ross? We'll see. My advisor would like to see me come back, but life's been too good ever since. And I don't know. That last year is really just about writing a thesis, which I haven't woken up yet and said I want to go back to school and write a thesis.
So how so we have a number of hardware founders in the group, startups and entrepreneurs in the group. So how did you end up finding your co-founders? How did you guys get started? Obviously the failures taught you a bunch of stuff. How did you guys get started?
Yeah, no, great question. So for Zipline, at that point in my career, I had been the CEO of a startup you've never heard of. I'd been a founding member of a number of startups. I definitely knew I wasn't a CEO. I knew I wasn't someone who wanted to dedicate their life to managing investors and selling and closing. I knew my sweet spot is really in a laser focus on a customer and make the technology work for that customer. That's really what I enjoy and what I'm good at. And so I knew I was looking for my complement there.
Mm-hmm.
Yeah, I met so many people. I tried various, back then there's a thing called founder dating, which was a total disaster for me. I tried a thing. A lot of people, I made a little bit of a living after starting ROS in this company called Willow Garage, which stewarded ROS for a while before Open Robotics came along.
Yeah.
A lot of people would reach out to me saying, hey, I got a robotic startup I want to do, can you help me out? Can you want to be a co-founder, this kind of thing? I made a living doing a very simple thing, which is I basically convinced them of something I believe in wholeheartedly, which is okay, don't be a robotics company. Come back when you've got 10 customers for a need that actually matters. Yep. And of course, most people I told that to, I never heard from again. And a couple that came back, none of them are. Two of them came back to me. They both have successful companies. Neither of one I would call a robotics company.
Yeah.
Yeah.
So that's how you ended up with medical?
No, medical was actually even before that. Medical, I did I did kind of a weird mix of taking time off around undergrad and did some stuff in robots in MR fields. So basically robots without any metal in them, which is a lot, or any ferrous metal or magnetic fields in them, which is a lot of fun. Try to figure out to do biopsies and stuff inside of an MRI, inside of a live MRI. Yeah, that was even way before. And that's what I thought I was going to do when I went to Stanford. I was going to like keep going down the medical robotics, medical device route. And that's why I got disillusioned and started Ross instead. Yeah.
And so like with, actually let's talk a little bit about Zipline. So, for those that don't know, maybe you can just describe kind of what you guys do and, how did you find the problem that you actually ended up solving initially?
Sure. So to Zipline's customers, we are a fulfillment and courier service. We do that courier service with autonomous drones. Our first customer is the public health system of Rwanda. We started there about 3 years ago, since scaled to cover the entire country, 96% of the land area of the country. Last year launched in Ghana and have a massive operation, a much bigger one going there, and recently started launching in North Carolina, all doing the same thing essentially, delivering things like blood, vaccines, light medical supplies, snake bite kits. It depends a little bit where. When we started operating North Carolina at the beginning of COVID, we were delivering PPE, which I joke with people because normally the governments call us now to deliver blood. That's like the first use case where it's just like, we can have such a huge health impact and cost saving by managing blood efficiently, because blood is scarce and rare and so on. And which, by the way, is exactly why we started with PPE at the beginning of COVID. Like, who would have thought it would be scarce and rare and need to be efficiently allocated, but that's what we were doing. Let's see how we got started. In that, like before starting Zipline, I sort of took this advice to heart of, get out in the world, find the thing you really care about before you start the technology. So we did that. And both the guy who became my co-founder and myself, we both have family in public health. And along that journey, they were nudging us of saying, hey, we hear about Amazon's going to do drone delivery, but like, if you really want to use drones, like you should go understand why these big vaccine campaigns that we keep hearing about get stuck on logistics, because maybe you could solve that with drones. And so we did that. We spent a bunch of time in Central America and in Africa getting to know the problem. And I'm a pretty skeptical person, so I went thinking like, okay, we're gonna go in the field and we're gonna learn all the reasons why this is just dead in the water. And sure enough, sort of adventure by adventure, we learned the opposite. We learned that like supply, my number one concern was there wasn't supply. So we'd be sitting there doing last mile delivery with nothing to deliver. And that actually is really not all countries, but a lot of these countries have really solved that problem. And then the other big thing that was clear from those early travels was just how much pull there was. I mean, we were meeting with presidents of countries off of a sketch deck. Wow. And that was, I've learned to be pretty skeptical about pull, like how much market pull is really there, and like how much you told yourself is there versus actually there. And this was that felt pretty real. And so and sort of the rest is history. Once we had met enough, really understood the problem well enough, how these supply chains work and logistics systems work and how the regulatory systems work. And there's a lot of details to work out there, but it got us pretty excited to go for it. So how did you meet with presidents? How did you get the meeting? So first of all, I'll credit a lot of that credit. Just networking. And to be clear, this is also how I knew I wanted to start this company with my co-founder. This kind of networking and this like ridiculous sort of hustle and sort of chutzpah, if you're Jewish, like I love that word. It just captures him really well. But it's just like it's a huge amount of on the ground hustle. And so between network and hustle, it was just about like, who do you know? Who do you want to see? I think that's half of it. I do think the other half is we were onto something, right? Like we're solving a problem that these governments have spent literally billions of dollars trying to solve over 20 years with motorcycles and trucks and fancy motorcycles and all kinds of things to try to get reliable delivery out when you don't have good when you're trying to overcome infrastructure. At least that's where our current first customer started with. So
okay. Yeah. So you had some videos. So what does a launch, for example, look like? Like, I mean, is there an example of what goes on? And
I'll just play some videos here in the background. Give me a sec to fuss with this thing I'm using. Oh, look at that. I'm a little bit transparent. Well, don't get freaked out by that. Huh?
We can also see
software I'm using, or my novice skills of the software I'm using. Yeah. So this is Rwanda. This is where we launched. I'll just let this play for a second. By the way, if you haven't been to Rwanda, it's an amazing country. The countryside is amazing. The people are amazing. Certainly when I was getting on the plane to first go there, I was grounded in the genocide, in the early 90s. As my thinking was, and this country has come an amazing distance from that in every sense of the word. Anyway, so this is our first distribution center that we ever built in Rwanda. On the left, that little tent you see, that's version 1. On the right, that building is version 2. And this is what a launch looks like. So, so we have inventory on site, so we can do these deliveries on demand. About a third of our deliveries are what we call emergency deliveries. So there's an actual patient who needs something with urgency. And so, those flights are getting in the air within about 2 minutes. But you can see sort of, I got to get new videos here. These videos are old generation, but you get the idea. Package goes in the body of one of our drones. It's a small aircraft, as you can see. The wing goes on, then the battery will go in. It goes through a pre-flight process, and then it gets launched off this electric catapult, which is what you're seeing right there. And for the geeks in the audience, but I imagine we have a few today. That's 0 to about 110 kilometers an hour in a quarter second.
Wow.
Yeah. And now that zip is that we call it zip. Sorry by the way, if you hear a weird bird theme reference, internally we use bird metaphors for all of our names. Right. So I forget to not do that with people outside of the company. And then anyway, zips is what we call our drones. So it's flying automatically out to the delivery site. This is what a delivery looks like, also with an older generation of drone, but you get the idea. Mm-hmm. So the drone's coming in, it's live compensating for wind speed and direction and so on. It drops its package. That's slow-mo right there, to be clear. Drops the package and then and it compensates, so that package will drift with the wind where the customer wants it, not in the tree or or whatnot.
So that seems like a few algorithms there to figure out that, like a lot of data coming in, not just from the drone, right? To figure out like where it actually needs to land.
Yeah, exactly. So it's got there's a lot that goes into estimating that wind speed and direction, actually doing that ballistic calculation in real time, and then dynamically adjusting in real time. And then there's logic on top of it that will do things like, well, basically, if it's not happy with what it's doing at the moment of drop, it'll just fly around and try again. That kind of thing. And then there's, as you alluded to, there's all kinds of routing software we had to build to actually build the routes to get to these sites and for the planes to know where it is relative to the delivery site and all that kind of stuff.
And how did you so one of the problems in Africa is mapping, right? Like how do you guys deal with that and random addresses, or what seems like random addresses?
Yeah, no, absolutely. Well, okay, so we started with hospitals and clinics, and that was relatively straightforward. We'd literally we'd get a GPS coordinate, and we go visit them and ask them, hey, so where do you want this to deliver, and so on. I think that the future of that in Africa is getting solved by a company called What 3 Words. If you're not familiar with them, look them up. What 3 Words? Okay. Awkward name, but basically what they've done is they've taken the entire globe. And they've created I believe it's 2 meter or 3 meter grid over the entire globe, and every point on that grid has a 3-word address. And it's been translated into like 60 languages now, and they did the optimization when they created this to basically disambiguate. So like if you're off by a letter or something like that, you're not gonna you'll be in a different state. You won't be just off a little bit.
Yeah.
Cool. Anyway, really powerful system. And so that's taking off for us in a lot of these countries, is What 3 Words, because they can even tell us like right on their property where they want it by giving us that address. So,
and it's global.
It's global. Yeah.
Cool.
Yeah. No,
Cool.
what 3 words? It's actually kind of funny. It was created for musicians who would show up to venues and not know like which back entrance to go into.
Yeah.
Right. And so like you could give the location of the actual door to go into anyway. And then it took off like crazy around the world. Like it's the national addressing system of a number of countries now, like officially.
Wow.
Yeah.
That's cool. Yeah, I'm familiar with a company in Kenya called OK High that's trying to map streets and homes and addresses. But yeah, interesting problem. So, you know, one of the things in the video was the drone doesn't land and then it comes back and you catch it.
And that's what I was just playing there. This is the landing. This is an example of the kind of fun stuff we've gotten to do at Zipline. And this is it's crazy looking on the outside, but what you're looking at here is, you know, when we started this, we went to the people who do the most drone operations in the world, the only people who actually do more drone operations than we do, which is the U.S. military. And they shared a ton of data on basically why their drones fail. And one of the most common root causes of failures is what they call hard landings, which is what it sounds like. You know, basically when you land an aircraft in general, if it's stormy, windy, you encounter the ground in a really weird load case. You can get some load cases going through your airframe that basically degrade your airframe in ways you don't understand. And so this was designed from the ground up to, in storms, reliably, gently land the aircraft every time. That's what you're seeing there. This was not the first idea, but the last idea of how to do that in a way that would have, you know, solid 5 nines of reliability. And this has been working great for years now.
Okay. So what things did you try? If this was a few generations on, a few iterations on.
We tried so many things. So the probably the craziest thing we tried was we were basically trying to do, you know, like the stunt people, like in movies, they drop on these big airbag cushions with these big vents that blow open. We tried that. Got a bouncy castle company to make a 30-foot high by 90-foot long sort of like 2-sided pyramid that we would basically belly flop into. Yeah, that was a lot of fun. It was a lot of fun until one day the winds picked up and the 6-foot stakes got ripped out of the ground, and we got a little nervous by how that would hold up in the real world.
Yeah, I imagine wind is a problem. What about with this? So do you have misses, or how do you know when to catch it?
Yeah, sure. So we definitely have misses. So the algorithm basically is trying to do. It's basically saying never catch the nose, never catch a wingtip, and after that, do your best to catch the tail hook. And so about 1 in 20 passes, it won't catch the tail hook, and the zip will just automatically go around and try again.
Okay.
And how does it do it? The zip has an INS system that's using a corrected GPS, and it's actually streaming that data to the ground at about 30 hertz, and the ground system is using that to trigger that. We call it the snap decision. Basically, when it's going to snap those poles up or not. Actually, if the ground system isn't happy, it'll just go down and let the plane go around, and vice versa.
Yeah. So you know, the other question I had was, here, for example, with the FAA, one of the things with the drones is that they don't want them dropping out of the sky, right? If a battery fails or something happens. How is that? I mean, are you guys dealing with those scenarios? Like, how are you doing that? And how does that compare in Rwanda to here, right? Because you guys just announced a deal with Walmart too recently. Congratulations, by the way.
Yeah, thank you. Yeah, definitely. So, I mean, basically, there's 2 answers to the question. The vehicle itself has many layers of fault tolerance built in. On top of that, there's a lot of things we do to kind of augment the onboard fault tolerance with things we do in pre-flight and other things to basically push those statistics where they need to get to. And then basically wrapping the operational fault tolerance, we call it. Operational as in like things go wrong, it can keep flying. Wrapping all of that fault tolerance is a fail-safe system that's a parachute landing system. I got a video of that I can play while about that.
That would be cool.
Let me find that. So this is that parachute landing system being deployed. And this way, like kind of in that worst case, there's basically 2 reasons this will happen. That I mentioned hardware faults, and so if there's multiple hardware faults, this can happen. And then also basically really extreme weather is another reason we have to land by parachute.
Okay. Okay. Yeah, that makes sense, because you're not going to be able to guarantee you're going to catch that cable, right?
Yeah. Well, no, it's less about the recovery. Like if we make it back, we can almost always land it with that fire. This is more like literally, we're out, we're making a delivery or on the way back.
Oh, yeah.
Up in a thunderhead or in a downdraft.
Yeah.
Plane's quite capable, but one in sort of 10,000 flights right now, one in 15,000 flights in that range. We will get ourselves in a weather situation in transit where like the plane just cannot handle it. And
so how do you recover these? Do you recover them?
Yeah. Well, the planes have a little sticker, right? If you find this number, please call. And literally every single time this has happened, we've gotten that call. And then of course we know where it was because of it's sending live telemetry back. So we know where to go anyway, generally. But yeah, it's really fun to see, like, we've had many times we'll be watching on our on our iPad, we'll be watching the plane, it'll parachute land and then land on the ground. Then 20 minutes later, all of a sudden it starts moving. Like somebody found it, picked it up, and is like carrying it down to the local village or road or wherever we happen to be. And then they call us and they're like, "Hey, they're in Rwanda and Ghana, actually, they're publicly referred to as air ambulances." Oh. So on Twitter, or even when we get the phone call, it's like, "Hey, I found your air ambulance. Can you come get it?"
Well, at least they're not going to damage it, right? If they just somebody's it's
the acceptance we've gotten is really positive. No one's tried to walk away with these things, and generally they we're solving. I mean, part of the reason these governments hire us to do this is because we're solving a very visceral, politically important problem that everybody cares about a lot.
So you mentioned keeping supplies, and I mean you're dealing with cold chain, right? So how do you get all of that? Do you store it all over there? Like, how do you manage all of this?
Yeah, so we have, at the little distribution center you saw, we have a whole storage facility in there. So we have 8 different basically types of cold storage devices at the different temperatures and agitation levels and things. And so we're maintaining all of that. I don't know if you want to just let me change pictures here, so you're not just sitting here staring at this thing going over and over again. Here's a picture. And so like, for example, in Rwanda and Ghana, we basically have 3 supply chains that feed us. We have the blood supply chain, which is basically the national blood bank system. And so for the way that works is that every day at 6 p.m. there's a call between us and the blood bank, basically negotiating based on what they have, what we've been deplenished on, and we keep numbers and forecasts. Our goal is to sort of 99.9% of the time have what could be ordered, right, in terms of forecast. And so they'll basically negotiate and decide whether or not a delivery is needed to replenish us in the morning. And so we'll get anywhere between 3 and 7, really busy weeks, 3 to 7 blood deliveries a week. And then, of course, for things that are less perishable and have a longer shelf life, the deliveries are more like once a week or so, maybe once every few weeks to keep us stocked up.
And then what about here? You mentioned North Carolina, and then you've got this trial with Walmart in Arkansas. What's the setup there, and is it blood as well? What are you delivering? What are those for?
Yeah, so I mentioned North Carolina. We started with COVID, which I was not expecting. We started with PPE for COVID, which I was not expecting.
Right. Yeah,
which is a lot, it's just kind of wild. Of all the things to deliver with drone, I wouldn't have thought gowns. But so so what's coming? So by the way, that contract with Novant Health is a big health system in North Carolina. What we'll do once they can get around to this, basically after COVID gets enough under control for them. The reason they contracted us was not for COVID. It was for there's a big push around the world and luckily in this country too to really move healthcare to the home. And so Novant has this whole plan. They're basically scaling up nurses and assistants who will be doing a lot more home health visits of certain conditions that are just far more economically treated at home than coming in person. And so basically they want us to be the physical side of that. So if those nurses or physicians need something while they're at a patient's house, we can deliver that thing for them. So, and it's funny, like when I originally heard the concept, like, okay, so like tests or splints, I don't know, I was trying to think what needed to be just in time. And they were saying, yeah, that, but just even pills.
Yeah.
Like the number of patients we have who just get their pill organizer wrong and end up in the hospital. It's like, if we can deliver the pills and while the nurse is there, she can like, or he or she can put it into the dispensers just right. That right there can really improve health outcomes. And there's obvious, actually, probably in my opinion, everybody's familiar with the Affordable Care Act. The more important side of that act, if you're not familiar with it, is everybody's heard about, basically the marketplaces and all this stuff, but there's another side of it called the value-based care, which is essentially transitioning our health system to move away from fee for service, basically charging for each test and this kind of thing, to, for this kind of patient, you'll get paid this much per month in sort of a value-based system. To really change the incentives around how healthcare is delivered in this country. So
okay, cool. So that actually brings me to another question I had is so who is your customer? Like who's paying you guys money? Is it I mean it's the health? It sounds like the health authority.
Yeah, exactly. So in Rwanda and Ghana, it's their respective, it's the supply chains of their respective public health systems. And to be clear, they have very high functioning public health systems. National level public health systems. We're just starting to get into serving other verticals within those countries, other basically private sides of the health system. We did trials of bull semen delivery of all cold chain products. Like diversity of cows is a big deal. Anyway, here in the States, it is health systems. Not public health systems, but it's at least not yet. It's health systems. Like Novant Health is I think it's a chain of something like 400 or 500 hospitals and health clinics around North Carolina. Walmart's a little bit different. We're focused with them on their health and wellness products, basically that they're CVS kind of pharmacy products. Right. So it's all relatively similar all around this, people getting their health care at home and
okay. Oh, so and then so they're paying you based on flights. How do they pay you guys?
So our pricing model varies by customer. I'd say the one that seems to be scaling the most outside of the U.S. Is what's going on in Ghana, and it's actually kind of like an insurance policy. We're kind of selling a stock out insurance, which is a pretty interesting and deep relationship with the customer. But it also enables us to sell the value of what we do, which is eliminate stockouts. And also have in a lot of ways with a customer like a health system, having that deep relationship is powerful to really solve the actual problem rather than get kind of like as soon as customers look at us as like, well, how do you compare in cost to a motorcycle, which we are competitive in places like Rwanda and Ghana, it misses the point, right? Which is, motorcycles aren't solving the problem. You hire us for a gap essentially. Which is a weird pricing conversation because, of course, governments, they need to do all this anti-corruption and they need to baseline it against stuff. And so it's hard to baseline a new thing.
Yeah, exactly. No, that's very true. So I'm going to switch a little bit to kind of the hardware startup type of questions. Sure. Where are you guys making these? Are you manufacturing yourself? You have a third party doing it?
Yeah, so we're making these ourselves right now, and that reminds me, I can play another fun video for you all. Give me 1 second to find it before I'm not the best multitasker, so 1 second. Here. So we do final assembly and test in South San Francisco. So that's what this is a video of. So the drones and the ground equipment are all very modular to make field service really easy and foolproof. And so, we do the final integration and test of all those modules at our facility in South San Francisco. And one fun fact about those modules is they're independently waterproof. And so that's just one detail that kind of explains what I mean by trying to make it easy to do field maintenance and really enable that sort of scale in the real world. And so we build, everything you saw in those other videos: launcher, heater, recovery, battery chargers, the batteries, of course, the drones themselves, and all the spare parts. And this is a big investment, as I think you can imagine.
Yeah.
We're right now going through the FAA's production certification process, which is good times.
So up here in Seattle, we're in aerospace country, right?
Yep.
Why did you guys decide to build it yourself and not use a contract manufacturer? Or do you knew how to get through certifications and things?
Yeah, it's a good question. We looked at it. We've looked at it a bunch of times. And by the way, we are moving more and more to contract manufacturers now at that module level.
Okay.
Basically, once a module is stabilized and our production test for it is stabilized, and we know how to make it and we know what matters and so on, we're starting to move a lot of that out, which has enabled us to, with a still very small, sort of relatively small footprint. We're doing, solid 10 planes plus supporting equipment a week, and we think we can get that to like about 5 times that as we outsource these modules. So we are doing that now. We didn't start there for a bunch of reasons. I think they come down to a few things. Design maturity. Like when we started, sort of having total control and being able to iterate and fix things quickly was really important. I think beyond that, like we were just kind of in a weird spot. We've been in a weird spot. That's starting to change now, but we were in a weird spot in terms of volume.
Yeah.
Right. Like it's just safety critical. It's relatively low volume. We have cost sensitive customers. So like we couldn't go to like an industrial equipment manufacturer who's used to, right, a typical like biotech equipment, right? Your BOM is like 5% of your sales price, right? Like our BOM is much higher percentage of our sales price. And so the margins weren't there for that kind of world. I think those are the main reasons.
Okay. And then, and obviously you guys did the design work yourself, because you're one of the things that we have a number of members in our group who don't have a hardware background, sometimes not even software background, and they look for help starting with just getting the design done. But it sounds like you guys had the team, had the background to at least get it going.
I mean, over time we built that team. I mean, this is a pretty weird hardware project, and like safety critical is obviously something you want to avoid if you can in a startup, and safety critical hardware and software, like each of those are just huge tar balls of engineering skills and production tests and quality and all these things. It was where a lot of things, back past in my career, I've used like ODM houses and who will do designs, full designs and manufacturing for you. Like, I mean, to be clear, I don't, if you can do that for your idea, don't do it yourself. If I thought we could have a chance of doing that, I definitely would have left it that chance. But for so many reasons, I ended up just not convinced we could pull it off.
Okay. So, out of all the things that you guys have built, you've done, you've got a whole bunch of advanced features. What would be some of the ones that you're most proud of, and were the hardest as you're designing, engineering your product, the zips?
Oh, interesting. Most proud of, like in terms of like a design decision or a feature, something like that.
Yeah.
I think let's see. That recovery system is up there. Recovery system. One of the things that really enabled us to do, like, obviously for a lot of delivery drones, if you want a long range, you kind of do one of these fancy like hovering VTOL systems, because you're like, well, how am I going to land and take off? And the challenge with that is now you've made your drone just much more expensive and much bigger and much harder to design. Like it's just it's hard to explain how it's not like twice as hard to do that is what we did. It's much harder. And what that decision enabled us to do was basically bifurcate the engineering work, right? We basically I had to sort of tell the team, like, trust me, like, we're going to figure out this landing thing. Multiple plane team, we're going to figure out this landing thing. And we had, a couple people on the recovery system saying, like, we're betting the company that you're going to figure this out. And enable those two things to move completely independently.
Cool.
And that was a huge speed up. That's one interesting example. By the way, one fun detail. Part of the reason we were able to do that is that we had the recovery system that we actually launched in Rwanda with was not what you saw in that video.
Oh.
So what we launched in Rwanda with was okay, bear with me as I describe this, okay? So instead of a fixed little tail hook that we would go up and snap and grab, it was a deployable tail hook. So a 1.5 meter long deployable tail hook. So very long tube with a hook on the end. They would drop down out of the plane.
Oh,
I would catch a line that was literally strung between two deep sea fishing poles. And using, on a fishing reel, there's like a knob you turn to set the friction that will pay out.
yeah.
So we would dial that in using a literal fish scale. We dial that in. And so the plane would come in, fly through, snag this line, and then, whiz, would go out. And then, by the way, that same bouncy castle company, they made a different mat for us. It was just flat, 2 feet thick, flat, 60 feet long. And this thing would whiz out and land on this mat. And that kept the plane team developing while the recovery team was able to make a lot of progress, even post-launch. And so that rolled into the operations actually like a year after we started operating.
Yeah. So, one in terms of the drones, is there a plan to have those land? Because when I was doing some research into this, it looked like I think it was DHL has some cold chain drone that they're saying it lands. Like, I mean, is that something that you guys plan on doing, or is there no need for it today?
Probably not. So it really depends on your use case, right? So from one of our distribution centers today, and while I'm talking, I'll pull up a picture here. Like we're delivering, right now about 300 delivery sites is our busiest distribution center. And now as we're just starting to transition to, this is one of our distribution center locations out of Ghana, just outside the capital of Accra. And those are all the yellow dots, the orange dots. Those are all the hospitals and clinics we serve. And so you can imagine as we start transitioning now to patient home delivery, we're talking about tens of thousands, hundreds of thousands of delivery sites from one location. And so like the safety sort of case around the delivery is really, really, really important at that kind of scale, or even at the scale we're at today. And touching the ground with something that flies is just a dangerous thing to do for a safety point of view. And you're a very good chance you're going to damage your drone, especially if it's storming out. And so delivering this way basically makes that delivery experience scalable in a way that landing is just never going to scale. Don't worry, we have some things up our sleeve that will roll out in a few years that will make the delivery experience better.
I'm sure.
We're still not going to land.
Yeah. No, I was just curious. Like it makes sense to land, but then that's more complication, right? Longer before you get something that's working and delivering.
So many more things that can go wrong.
Yeah. No, I hadn't thought about that. So for folks who are attending, if you have any questions, just post them in the chat window. I have quite a few more. I can carry on, but if you do have any more questions, or if you do have questions, please post them in the chat window. And like I said, here we go. We have the first one. So I'm gonna have maybe Christopher can ask it. And Christopher, you have a question? How many sensors does an individual drone?
Yeah, you need me to frame the question. I was just curious because looking from your video, it looks like the drone is actually really agile in terms of its decision-making process. So I'm thinking that it has to be receiving a lot of information on its own, because you wouldn't want any sort of delays, I would imagine, in terms of that process. So I was just curious in terms of build, how many different information streams is it getting at one time to be able to shoot it, land a package somewhere?
Yeah, less than you would think. So basically, the way we operate today is you can kind of think of it like basically the drones have these highways in the sky that we have pre-programmed using data we basically analyze and synthesize offline. And so those drones, they have a lot of onboard sensing, like air data redundantly and IMUs and things redundantly. But generally they'll go do that mission, even if communication systems are completely down. They'll go make that delivery. And that was an important design sort of requirement for our customers, right? They in a lot of these cases, literally somebody's life can be in the balance if we're late. And so we needed to design this, architect it so that basically nothing out of our control could affect a delivery. So, and one interesting example of that, just as an example of what I mean by that philosophy of really pushing hard there. Let me play this video. This is interesting. I'll find it. Yeah. So like our control surfaces, for example. So our control surfaces are redundant. So we can lose a control surface and it can go hard over, it can oscillate, it can fall off, anything, we can keep flying. But if that happens and we're outbound, we have to turn around and fly back. When I say we have to, like that's part of our commitment to the regulators, is that we'll do that from a safety, from the point of views that they care about. But of course, turning around and not delivering blood is not something our customer, that's the opposite of what they want us to do. And so this is something that is essentially trying to optimize the two things, right? So this is our operator UIs are these refurbished iPhone SEs. And if you're familiar with sort of what you can do easily with QR codes, you can estimate a 3D pose quite accurately, especially at a little oblique angle. And so that's all we're doing here. So what's happening is that the camera in the phone is directly measuring the angle of deflection on the control surface. This is done, sorry, I should have mentioned, this is done on the launcher pre-flight, before every flight. And it's measuring the control surface angle. You'll see the control surfaces immediately start to dance around a little bit. And then the software is checking to basically say, like, does this look good? Does the backlash look right? It's a very sensitive sensor. And so we won't pass that wing if anything looks off. And this is to optimize the chances that we make a successful delivery, right? Because this sensor is so sensitive, we've been able to detect servo gear trains that are starting to fail before they fail. We've detected control surface linkages that are starting to come loose before they actually come all the way loose. And so anyway, I thought that was an interesting way of answering your question of kind of like, basically, what are the things we really focus on? On the radio side, we do the vehicles. They have 3 radios. They have a line of sight radio. It's a good to about 10 kilometers. Our service radius is 80, so it doesn't work for most of it. And that's for talking to our ground systems, but also talking between zips directly, between our drones directly. We have cellular modems, and we're actually about to roll out redundant cellular modems. This is a fun fact. Believe it or not, we're rolling out redundant cellular modems because of how much worse cellular networks are in the US. in terms of coverage and quality.
That's ironic.
Yeah, did not see that coming. Anyway, cellular modem. So sorry, line of sight, cellular modems, and then a satellite as the tertiary backup. That's so that in that worst case, if everything is not working, we still know where our drones are and we can still get a command out. But our commands are very simple, right? You can command it to come home. You can command it to hold its position. You can command it to deploy its parachute landing system. Those are the three commands.
Great, thanks. That's super interesting. I really appreciate the answer.
Yeah, sure.
So it sounds like, do you have a bunch of pre-flight type of checks, like like a pilot doing a walk around a plane? Like, do you have something similar that you do?
Exactly. It's literally, we call it the walk around check. So it's nose to nose. It's done on the launcher. So whoever the person who assembles the plane onto the launcher, putting the wing on and the battery in and so on, they will immediately start this pass. They have a whole bunch of things that they're checking off the list as they go. Meanwhile, the drone itself is doing about 1,000 internal checks. So it'll fail itself from one bus to another and make sure its buses are working. Same with, it'll check all its power rails. It'll check basically all of its servos, basically look healthy from a power consumption efficiency point of view. And meanwhile, the human operator is doing all these manual checks as they go around, including this one you see here. They do it, of course, on each wing and on each part of the tail. And then only when those are all done, takes about a minute, when only those are all done, and we have the airspace clearance. We have a person we call pilot in command, or we call it zip controller. But if we have airspace clearance, which we have to be careful, it's obviously a professionally managed integration in the airspace.
Yeah.
Then the launcher button enables, and when you hold down the launcher enable button, that spins up the motors to a very low power setting. And then the zip does a final check there to say, okay, are my primary propulsion motors healthy and looking in spec? And only then does the launcher button actually even enable. And that's the end of the pre-flight. And when you push that, it's off.
So actually, I just thought of a question related to what Chris had asked. So, we're IoT meetup, so I have to ask you the edge question. Right? In terms of architecture, like, what do you have on the zip? Is it like an Arduino, Raspberry Pi, custom board? And then you mentioned ground systems. Is it like you have multiple systems on the ground, or is it just the distribution center?
Yeah. So, when I mentioned ground systems, I'm talking about the base, all the various components that make up a distribution center.
Yep. Okay.
I can talk about those. So like, what are we running? The good question. So it's a custom architecture. On the current generation, and this is going to get dramatically simplified in the future, but we're just breaking ground on this, which is exciting. But current generation, it's a very distributed system. So it has actually 11 different processors around the aircraft. One of the things I should mention, like, so I thought I knew what I was doing with robustness and fault tolerance from my experience in medical robotics. Yeah. But medical robotics, generally speaking, is fail safe, right? So things go wrong, you don't hurt the patient, but usually, you don't continue the procedure as if nothing happened. Yeah. And so that was my experience set. And then I was like, well, fail operative can't be that big of a step. Yeah. It's a huge step. And actually thinking through all the crazy ways that you can damage or have a fault in your system and how you have to distribute functionality and things across a system like this. Anyway, that's a big part of the reason that avionics are so distributed. Yeah. And so there's basically an ARM processor, which is a SAMI 70, which is most of those nodes. And then there's the primary flight node and the backup flight node and the fail-safe node. So that there's basically 2 flight computers that run the real-time stuff, and then the fail-safe, which is on a separate board with its own power supply to deploy that parachute. Okay. All 3 of those processors are Hercules processors. If you're familiar with that TI family, they're lockstep. They're internally each processor. They're dual lockstep processors that have pretty robust, basically error checking internally.
Okay. Yeah. Okay. Cool. I see a question from Stephen. Stephen, do you want to ask your question?
Yeah, thanks. Hi, Keenan. I'm Stephen Morris.
Hello.
I'm interested in your failures. I'm trying to get something going, and there are times when I lose a little bit of momentum or enthusiasm about certain things. And you said you had a few failures. What kept you going?
A few, I don't know. Maybe a few would be an understatement over the years. Like, I still remember the first time we did a custom airframe design that was like optimized to actually solve our customer problem. And on the first flight, we turned it into a pile of dust. Anyway, yeah, for me, it was actually really just, this is one of the things I just love about having customers just deep in your design process early, right? And going and selling as early as we possibly could. Even at that point, we didn't have signed customers yet. We didn't have Rwanda signed yet, but we were deep in it with a number of customers in terms of contract negotiations, and we knew they wanted it. It was a matter of working through all the government, roadblocks and things. But like having that interest from them, I think that just kept us all going. It was actually really interesting because in some ways it was actually really intense. Like towards the end of our development of our first system, the Minister of Health of Rwanda was literally sending us pictures of people that passed away and saying, like, when are you going to ship this thing? Because we need to use it. Because we have these. It was that intense. But while that was intense, the flip side of it was really interesting. It created this really positive culture, right? Like basically, because we were so focused on getting it done, like nobody dwelled on failure. It was just like, okay, what did we learn? What are we doing next? Let's go, right? That was the attitude all the time. And it was actually probably the most positive I'm pretty sure every time you ship anything, like especially with hardware, it's going to be intense, but it was definitely the most positive, intense, shipping experience of my life. Even though had this like undertone that I was actually worried because we were getting so much sort of basically pressure from our customer about how much they wanted it. And to be clear, as you can probably imagine, we were a little bit late on our initial schedule for our first system. Anyway, created a lot of pressure, but I think that was really what kept us going. Like it became this thing of just like, we got to do it. Like we got to figure this out.
So you had a team of a handful of people from the beginning. So you all were in it together and had enough funding to go for a couple of years, or?
Yeah. So we did a first flight in Rwanda, just about 2 years from we started, a little less, I guess. We started in the beginning of, and then I guess it was into 16. Yeah, so it was just so I guess it was just 2.5 years. Actually, now that I think, sorry, I'm bad with schedule math. 2.5 years from when we were just 2 of us. We had built the team and gotten funding and sort of gotten to the point where that first thing was fielded. And to be clear, we fielded that with a relatively small team. Our team was gotten quite large now as we're scaling up pretty aggressively with and getting ready to scale up even more aggressively. But back, we launched the first product with like 10 engineers, and that was everything. That was aero design and controls and everything to do with software to make deliveries and like all the mechanical hardware folks to launch the plane and land the plane and build the plane and all that stuff. We've come a long way since then, but that sort of MVP, like as much as we could keep it simple, that's what it took to get this thing shipped. Which is also, it was a fragile time too, because I'm sure as I'm sure you're living, like, it's a team. Yeah, every team is like a quarter of a person, right? It's like you have no redundancy whatsoever, and everybody's spread really thin in terms of skill set and expertise, and you're just kind of by hook and by crook trying to figure out like which outside expert will get on the phone for us for half an hour to potentially help us like get past this thing we can't get past or whatever it might be. A lot of that kind of thing is a lot of just reading, going and reading and reading and reading. Yeah, it was a fun time.
Thank you.
So speaking of funding and funding as a hardware startup, which is, it's already hard to get funding for a software startup. Hardware, you just, you have to be insane, it seems like sometimes. How did you guys go about getting funding? And you also started at Techstars Seattle, right?
The short answer to funding is just, I'd say two things in the short answer, and I'm happy to give a longer answer if you have time. Yeah. The short answer would be like I don't know. For me, and don't get me wrong, people have proven this wrong, obviously, but for me, like, don't be a hardware startup. Like, don't have that be the actual product, right? Like, have the product be hopefully some kind of service or whatever that might be, and the hardware is the enabler. That's one thing. Second thing is just customers. Yep. Like that's really what it came down to. Yeah. It's what enabled our development to move fast and be focused. It's what made investors take us seriously. It was that, like, the customer thing, I think, was, in hindsight, it was just a transformative effect on the company to be so maniacally focused on customers before we even really started the tech. It was hard, right? Because we were selling something we didn't have at all.
And you want to go and build it, right?
Literally, there were times when they were like, we're going to send a delegation from this another country in Africa that ended up not being our first customer. But anyway, this country was like, we're going to send a delegation to Half Moon Bay because we got to see this thing. And we're like, oh shit, like, we better make it. We actually better make it. So anyway, it was that kind of stuff is tricky. And you don't go worry. We didn't tell them it was all working at the time.
Yeah.
But like, they just assumed, why would we be selling something if we couldn't demo it? It was tricky to manage, like, the horse race of those first customers and developing the first system and getting that all to come together.
So and then so when you were part of Techstars here in Seattle, so you didn't build anything. You were just doing validation. Is that what?
Yeah. That was even before that. That was like in the earliest possible days.
Okay. Okay.
Yeah. So, but, the investors, like, that really got excited. I mean, like, the way we brought in, the marquee investors like Sequoia and eventually others, like, I mean, that was customers, right? Like, at the time, this was when a bunch of drone startups were happening. And, I still remember when the day the whole Sequoia partnership came out to our cattle ranch in Half Moon Bay, where we did all the development in the early days. We picked, it's literally like giant cattle ranch, great ocean views, a couple modular trailers, that we worked out of, and the kind of thing that construction trailer kind of thing. And and they came out and it was raining, but like, we weren't demoing. We had like 6 planes in the air just because that's what we were doing at that point in time. Like, while they were driving up the dirt road on the cattle ranch, and they're like, whoa, it's raining, and they have planes in the air. And then they like got to see things, and like literally all we talked about was like how close we are to shipping and how excited the customers were. And I think that, I think most investors have been pretty tuned to, basically not get excited about the technology, or not get overly excited about the technology.
Right. It's you have to focus on the outcome you're trying to deliver to the customer, right?
Exactly.
The tech is part of it, but I totally agree. That's awesome. So we're at 6 o'clock. Anybody else with the questions? Otherwise, I've run out of my questions that I had, but if anyone else has questions, you're free to open up or actually post them in the chat window, or you can just ask. Otherwise, this was really good, Keenan. Thank you so much. It's awesome what you guys are doing.
Absolutely. This is a blast. Trying to think if there's any fun video clips or photos I didn't think to show you.
Yeah.
Well, I can explain one I showed that was kind of fun.
Yeah.
Here, this one is where'd it go? Oh, here, I got to show this one. Okay, so all right. So let me just talk about weather for a second, because testing is like half the battle if you're taking stuff outside. So like if this is rain in Rwanda, like it's very heavy, like 2 inches per hour, 3 inches per hour rain rates. It's like kind of thing that would flood California if it happened. So we do a lot of testing for stuff like this. And what I love about the testing is like, it's like layers. Like some of it is like super craptastic. Well, sorry, that's an internal term, but basically you'll see so this video, what's off screen to your to the side there is just like the biggest blower you can buy on Grainger, basically, and a garden hose attachment, and it gets up to 130 km/h, just like blasting rain, and it helps us tell, well, in this case, what's the wet weight of the vehicle, and does rain drive into our seals where we don't think it will. And then we build fancier things, also, very hacky, right? This is so what you're seeing here is an environmental chamber built out of a 20-foot shipping container. So we got one. You can buy them for like $1,000. Put a bunch of insulation on it. Put heaters in there, humidifier, hoses with a pump and rain. And then we built this thing called a wiffle tree, which, if people are interested in what that is an aerospace thing that basically reproduces the worst case 3G turbulent loads, basically flying through storms. And it's an accelerated life model. And this was an intern project. This thing's running up and down. Like when this thing runs, like in the next building, it's running. Like that's how much power is going up and down to drive this thing up at 3Gs. And it's great. Like it tells us, do the wings flex off, obviously, do the blind mates between the wing and the body fatigue. Half the weight of the plane is just the battery, that battery pack. So like, do those latches come undone? Important details. Do they wear out over time? Anyway, I love the testing stuff. This is another one. So another shipping container. This is a 40-footer. This case, we bought a used refrigerated container, because those go down to minus 20 C. Just out of the box. The ones you've seen, the 20-foot the C containers that have built-in refrigeration in them. And so what you're seeing on the left here is our recovery system getting cycle tested in minus 20 C. In the middle, we actually create conditions that create snow, which I just love. So you can't see anything at all in the middle one. And then on the right, this is a slow-mo video, same tests, but running at 50 C. And of course, we have a team that we have a reliability lead who develops essentially the life model for these kinds of tests to make sure these are rigorous and repeatable and things. This kind of stuff is super helpful. Like learning any of these failure modes in the field, just the worst thing ever.
You
and you can do it on a shoestring, I think, is part of what I'm trying to get across with with these videos.
Your own wind weather tunnel.
Exactly.
Build your own. That's awesome. How are you creating the snow?
Basically create the right. We literally just pump humid air in there, and the conditions are just right that it will condense into snow. This is a relatively new thing for us. This was not the 12-person when we launched 3 years back. This is like, we actually just hired our first, I guess about the beginning of the year, I should say, just COVID, time flies. But anyway, in January, we hired our first meteorologist. World class, basically machine learning guru who spent the last 10 years at Weather Underground, the good one, not the bad one, developing algorithms. And he's like, yeah, we can create snow in this chamber. Like, let's just change a few parameters. And like, sure enough, snow.
Wow. That is cool. I never thought a meteorologist for a startup. That's pretty cool.
Oh, it's a big deal for us. Weather is now, it wasn't for the first years. In the early years, like we had all kinds of reliability problems that had nothing to do, like weather was this like distant out thing that barely ever got us. And now we're reliable enough that it's the thing that gets us.
Yeah.
And so now we gotta get better at the forecasting and we call it near casting, sort of with planes making their own decisions based on their weather estimate of what they're about to go into.
So that will be pumping more data onto the plane, or
it's a combination of a lot of offline processing.
Okay.
Of data for like historical reasons.
Yeah.
We'll see how we actually crack this. What looking most promising right now is using very low resolution but high rate weather satellite data to basically, like literally, like in a matter of hundreds of meters, be like, hey, there's a thunderhead forming right in front of you, and then getting that command to the vehicle. Part of the reason we like having like satellite backup is that, like, even if we don't have cell, we still want to tell that vehicle, please turn around. You have to fly into the thunderhead we can see from space. Right. It's a combination of that, and then using. So that's one class of weather challenge, and the other class of weather challenge is actually best done with using our planes as like historical weather stations, because those other class. So thunderheads are not very terrain relative. They're a little bit, but not very. But then there's a whole other class of weather and basically wind turbulence effects that basically are literally the turbulence off of terrain.
Right.
So that stuff we can kind of predict just based on which way the wind's blowing and the 3D model of the terrain and stuff. So yeah, it's a fun world.
Very cool. That was it for me. Actually, you know what? I was going to ask you. So I found a YouTube channel that was 10 years old where you built some robots unloading a dishwasher, delivering a beer. What happened to all that?
Yeah, actually, that's kind of what became Ross. So that robot you saw with
PR1, right?
Sorry?
Is PR1?
PR1, the PR1 robot. That was one of my first grad school projects, and then that's what we used to get funding for Ross and a robot we called PR2, which you can also Google, which looks way better than that robot. And we ended up making a bunch of those, and that actually was the nucleus of what became Ross. Is basically, it was sort of a chicken and egg problem. We set out to create a common software platform for next generation robotics, where you have lots of sensors and you have lots of actuators and things. But we needed enough of a common hardware platform to kind of get it going. And so PR2 kind of filled that void. And then, there's actually someone on the web, I can't ever remember the name of the website, but they basically made a family tree of like all these robots. So if you look at like Fetch Robotics has a robot that's sort of a descendant of PR2. Literally this team from PR2 has now gone on and made all these other robots. But Ross is used all over the place now. Yeah. Like, I mean, a lot of the autonomous car companies are using Ross.
We'll have Cat in a couple of weeks, and I'm looking forward to that. All right. Any other questions? Otherwise, with the beer delivery, you're welcome to join our social hour next week. I'll send you a link if you have time.
Cool.
Otherwise, thank you so much. This was awesome. I think it's there's very few hardware startups that take off, and it's great to see you guys doing well. And I love the fact that you focus on the customer, because that's where it should start. So it's awesome.
Focus. Like, I feel like the goal of focusing on the customer has to be making your company not do any hardware.
Yeah.
Like, it's not always an achievable goal, but if you can achieve it, your life is just like night and day better. So.
Yeah.
But anyway, it was great talking with all of you, and I wish you all the best in all of your endeavors. And for those of you who are making hardware startups, all the best of luck, because it's going to be an adventure.
Thank you, Keenan.
Yeah.
All right.
Thank you all.
Thank you, everyone. All right. Bye, guys.
Bye, all.